R squared shows us the strength of our line. Where is my label? I want my label back. There it is. Come over here. And again, remember, R squared is a measure of strength, how close our dots are to the line. That's what R squared tells us. So which of these relationships is a better one to use to estimate the cost of our car? Which one of these is stronger? I'm going to turn off my squares. Which one of these relationships is stronger? This one? Yeah, how do we know that this one's stronger? Because my R squared is closer to 1. The closer it is to 1, the stronger the relationship. Because if we had a relationship that was exactly 1, that just means all of my dots would be exactly on that line. That is a perfect correlation. They do not deviate from our line of best fit. There is no space. So if they're exactly on the line, the correlation difference is 1. So as close as they are, we think that this equation is probably a better one to use. So if we look at the story in the text, which is behind my graphs, but it's there too. What could I do to estimate the value of Jane's car? Because we said Jane has a... I don't know. How old is Jane's car? How crazy is that written here? All right. Oh, I got it. I get the words from behind because I'm not actually seeing it. All right. Oh, if Jane's car is 9 years old. So using our equation that we got from our line of best fit, if her equation or if her car is 9 years old, what should she price her car at? How would we do it? What do the pieces in here mean? It says price equals minus $1,483/year, and it says age plus $2,4,259. What is this minus 1,483?
So for the original price you paid for every single year you've had it, you take off 1,200.
Yeah. So each of these cars have lost $1,483 each year. For every year older it gets, it loses a value of $1,483. Value. What is the 2,4,259? The what? What was it, Francis? What'd you say?
He said down payment.
Like our starting amount?
Yeah.
Maybe our y-intercept because we're in mx plus b. Oh, snap, because you were right. It was our starting amount. So this is our starting amount. So if I know that this is my m and that this is my b, does that help us figure out how we figure out the value of Jane's car?
Yeah.
How would we do it? Where are we putting the fact that her car is 9 years old? Because what this is, our equation, we've got y equals minus $1,483 per year. And And then we've got, it says age. And then it says plus 24259. So if her car is 9 years old, what do we do? Where? For what? For age. The word age. So even if I didn't rewrite it, I just, wasn't getting people to respond. So we've got our $1,483 we lose each year times the age. So if we're going to take this one up here, we're going to times it by the 9. And then we have to add however much we started with, the 24259. So how much should she list her car at? What should the price of her car be if she wants to sell it for the most she can?
There is like 10K.
It is minus 1483 times 9 because it loses value. You can also see that in our downward slope.
But you were right.
I mean, technically, we want to be specific, so we don't. Thank you. So her price for a 9-year-old car would be $10,912. If she just went to CarMax, they'd give her $500 and call it good. Like if you go to CarMax, they will give you as little as they can. They do not follow this as much as possible. So they're just a business that would really, really, really like to take your money for you to buy a car, but really not give you any money so that they have your car to sell. And make more money. They're technically not scamming, but it is scammy-ish. It's legal. They give you a offer, but it's not the best. It is usually quite far from the best offer you could get. It is more work for you to sell it yourself, but you usually get significantly more money if you sell it yourself. But it's a lot more work. So sometimes you're just paying for the convenience. Okay, so even if we have more information about cases, about different things, if we did our weaker relationship, we could do the same thing. Her mileage we have, it's 95,000 miles. I could do the same thing over here. We just didn't use this one because it wasn't as strong of a relationship. It's a similar relationship, but it's not quite as strong. So when we're looking at data and we're looking to try and choose which data we might want to use, it's really helpful if we can figure out which relationships are the strongest. Okay? So, when we are looking at Canvas and looking at the next things we have coming up, we actually have another question about this that comes up in the homework using this particular relationship in homework 8.8. That is called buying and selling a used Subaru Forester. Oh my gosh, data about selling used Subaru Foresters. What? That we just put together and put the equations together of? Oh my gosh, almost like it's relevant for the homework. So, use the information you have here. The equations we just built are the ones you want to have for the homework, for homework 8.8. So we're going to work with that. It has it listed at, it's on today for Canvas. 8.8, buying and selling a used Subaru Forester. It uses this same data set. If you didn't put the things together, I do have the data set linked in the homework as well. So you can pull it up there, or you can keep it open and use the information to answer the questions in the next 7 minutes. Because we have 7 minutes left in the class. So, I'm going to clear my ink off the screen. But I would recommend going and doing this homework because you have all the information on your screen about it unless you close code out. You should have all the equations up there that you need for this. Okay? So do the thing, ask questions if you got them, but the data that we just put together is the data you would want to have for this homework.